Okay, so we have many such problems to ask us to find a minimum value, maximum value, or largest value, or smallest value. So we call those just the extreme value. Okay, so we want to find the extreme value under some conditions. So for example, like we have this condition, we have two numbers a and b, and their multiplication is 12. We want to find the largest value or smallest value of a plus b. So we have many possible ab, right? So let's say if they are positive integer, ab equal 12, so a b could be 1, 12, right? So this ab equal 12, right? Or could it be 2, 6, right? Or could it be 3, 4? Or could it be 4, 3? Oh, these are same, like 6, 2, and 12, 1. Okay, so for each case, we can find the a plus b. So here a plus b is 13, here a plus b can be 8, okay, 7, right? So we can say, for a plus b, so largest, this largest, and the smallest is thus, right? Smallest. Okay, so here we have a conclusion in general. So if a times b, the multiplication is constant, then the smallest of a plus b is, like in here, in this case, like a and b are quite close or equal. So when a and b are close, okay. So now let's consider the problem. We know a times b equals 36. So what is the smallest value of a plus b? So we say when a and b are almost equal, right? So we just say this should be a and b equals 6. If a and b equals 6, then a plus b equals 12. So this is smallest. So let's check other one, like a, b. So a times b is so a b equals 36. So we have many source possible a and b, right? Let's say if a is 2, b can be 18, right? So in this case, a plus b equal 20, right? So more than 12. So smallest one should be when a and b are close or equal. Okay, so now let's consider this problem. If a plus b equal 12, so what is largest value? What is largest or smallest value for ab? So we can check, like, okay, so a plus b equal 12. So a b could be 1, 11, right? Or could be 2, 10, right? And 3, 3, 9. So could be many cases. So we can check, let's say, the value for AB. So in this case, AB is 11. Here, AB is 20. So here, AB is 27. So which one is largest value for a times b? So we find, how about 6, 6? Then a times b, 36. So we can see that this is largest, and this one is smallest. Okay, so here we have this conclusion. If a plus b is constant, then for a times b, So the largest value for A times B is when A and B are close or equal. Okay. Okay. So now this problem becomes either we have those are two whole numbers, and their product is 36. Then the largest value for this, like we say, A times B equals 36. So what is A times B is 36. So what is largest value for A plus B? So here's the largest. So we know this should be largest values achieved when they are differ as much as possible, not so close, right? So if they're close or equal, or this one could be like this is smallest, is like 6 plus 6. Okay. So we just check those two extreme situations. Like this is A and B closed. Like here A and B is most of the divorce, right? So the different the largest. So here the different is smallest. We just check those two cases, then we can determine which one. Okay. So for this problem, we say we pick a X from this range, pick a Y from this range. Then what is the largest value for this or this or this? So such a problem that depends what is a A, B, what is the integer is. So how can we determine this? So we just check extreme situation. Let's consider the problem like we say. Suppose X belong to X is in this interval, 3, 4. Okay, so Y is in this interval. We say 5, 10. So let's say, so what is X plus Y? What is maximum for this? Largest value or maximum value for this? So we just check, let's say, here very easy. We just check X largest value. So X is 4. Y, we can pick 5 and 10. We just pick Y equal 10. So we find Y equal 10 is largest, right? So how about this one? X over Y. So here we just check it out. X can be 3, 4. Y can be 5, 10. So those X over Y can be 3 over 5 or 3 over 10, right? So we can like check it out. 3 over 5, 3 over 10. So 4 over 5, 4 over 10, right? So we just pick it. We just check those numbers. Which one is smallest? Or which one is largest? Let's say, okay, so we can find this one, right? So we have this problem here. So B, we want to find B over A. B over A is we want to find largest value. So B can be, so we just pick this two ending point. B can be 612. 600. A can be 200 and 400. So what is the largest B over A? So it's very clear that we can say this equal. Largest value should be this number. B chooses this, A chooses this, and so we find this number is 6. So 6 is largest. Okay, So here we want to find the largest quotient. So it can be formed using two numbers choose from the set. Or just we want to find a over b. So largest, this a over b. So this a can be choose one number from these 6 numbers. We just choose 2 of the. Okay, so b choose other number. So let's say, so we just check. Let's say, so if a choose the biggest number, suppose negative 24, we just check this, and the negative 24. So we want to guarantee this is a positive number, so we just pick b is this. Just check negative 24 or 2. So we say this number could be 12. So maybe this is not the largest. So maybe we check, let's say for other one, let's say, so can be 24, can be 24. So can we find 24? As I believe this is the largest, yeah. This is the largest. Okay. Okay. So for this problem, it says several students are competing in a series of 3 races. So if you own, if you are the first one, you can get 5 points. Second one, 3 points. Third one, 1 point. And then other one, 0 point, no point. Okay. Okay. So there are no ties, means like you can only one can get 5 points, one can get 3 points, and one get 1 point. So the question is, what is the smallest number of points that the students must earn to be guaranteed he will win in this competition? Like he can earn more points than other ones. So how many students? So we just check, actually we just check 3 students, because like only 3 people can get some points, all others just 0, right? Okay, so let's say suppose like first one, so 5 for 5 3 1, and suppose first race, second race, a also 5 3 1. Then in this case, let's say if a one can be guaranteed a will win, this case okay, like 1 5 3. Like what's the case? Like this way is okay, 11 point. Oh, in this case, a and b same point, right? So in order to guarantee he can win, should be the 3, so 3 5 1. So in this case, she can win, yeah. So in this case, I got 13 points. So 13 is smallest number. Okay. So let's check other. Let's say, can we have other case like first one a5, Okay, 3, suppose 1. Then 4, 5, 3. Not 4. 3, 5, 1. 3, 5, 1. Oh, so in this case, so if this guy get another 5, he will win, right? If this 3, yes. So in this case, also should be 13. Yeah. Okay. Let's say like a win. Yeah, 13 should be. Okay. Okay. So from those digits 1, 2, 3, 4, we can form smallest number is 1, 2, 3, 4. So largest one is 4, 3, 2, 1, right? From those digits, I'm sorry. Form 3 digits number. So smallest is 1, 2, 3. Largest is 4, 3, 2, right? So for this one, we say, what is smallest sum of 2, 3-digit numbers? That can be obtained by placing each of these 6 digits in one of this box. So we want to make the sum smallest, so we should put the smallest number in the first position. This first position. So we just put the smallest. So we just check. Okay, how about smallest? 4, 5. Okay. Okay. And second one, we put the smallest. Let's say can be 6, 7, and 8, 9. Okay. Yeah. So then they make the sum the smallest. Okay. So let's say. Okay. Okay, so this problem says there are 24, so the 4-digit numbers that can be from these digits. So we say why is it 24? Because 24 is just like 4 factorial, right? The first position we can pick one of them, so we have 4 choice. Could it be 2? Could it be 4? Could it be 5? Could it be 7? So 4 options, right? Then second one, so we already put one number, 1 digit. Then by now we have 3 left, so we can pick one of them. So we can pick. So we have 3 choice. Could it be A or could it be B? Could it be C? Right? So the same ways are here 2, 1. So this is multiply. This is 4 factorial or 24. Okay. So we list those numbers from smallest to largest. Okay. So smallest is really easy. The smallest is this, like 2, 4, 5, 7. This is the first one. The largest one is 7, 5, 4, 2, right? we have 24 numbers. So the question is, what is the number in the 17th position? 17th position. Like we say this is 1, this is 24. So what is 17? What is this number? Okay, so we just check. Let's say check last the largest number should be first is 7, right? So how many such numbers? We have 3 factorial. We have 6 of them. So if first digit is 7, so those numbers are largest. So we have 6 of them. So from, let's say, from 17 to 24, so let's say 17, 18. How many numbers? 1, 2, 3, 4, 5, 6. Okay, so those numbers, the first digit is 7, right? So we find, so this position, so first number should be 5. Yeah, okay, 5. So we can say this is first number is 5, but the largest thing, this is the second largest. So first number is 5, so largest is, let's say, so largest is 7, 4, 2. Then next one is 7, 5, 7, 2, 4. So this is the one in the 17th position. Okay, yeah. So here we see we have those 6 numbers. First position is 7. Then we just check next 2, right? Okay. So now for this problem, like suppose we have the 10 seats. So we have 10 people can sit there. But suppose they have some requirement, like nobody next to each other. So this means if I sit here, I hope here no guy, like that, right? So if we have 10 seats, so only largest number can be sit here. So then no people sit here, no one, like this. Okay, so we find we can only have five people can sit there, right? They guarantee next is the guy, nobody next to each other. Okay. So it says there are 120 seats. What is smallest number or fewest number of seats that must be occupied? So the next person to be seated must sit next to somebody. So we just check those cases, like okay, suppose like if people just sit here, just sit this close, okay, then the next one, here the next one must okay. So let's say if we have 120, 119, so only one seat left. So this guy must sit next to somebody, right? So this is too big, so we just reduce this number. So let's say, how about this case? Like, okay, some people sit here, so nobody here. Some people sit here, nobody, like that. Okay. Oh, what's the case? We can say what's the case, like that. So in this case, like if in this case, people say next person has to be seated next to somebody. So in this case, how many people, how many seats can be occupied? So we say this is like 60, right? 60. Okay. So how many chairs are needed so that 10 people can sit? Nobody nobody sit next to each other. Oh, so could it be like this, right? Chair. See, we just check this, okay, like that. So we 10 people can sit. Saying how many chairs should it be? So it should be 20, right? Okay, so suppose I want to pay off a 57 cents debit. So I can use 2 cents, 2 cents coin, 5 cents coin, 25 cents coin. So we have many combinations to make this 57. So we want to find maximum number of coins or minimum number of coins. So we say maximum number of coins. We just use this as much as possible, right? So this equal like 2 cents. 2 cents. I just use 2 cents. So suppose I use this x 2 cents, y 5 cents, z 25 cents. So we just have this equation: 2x plus 5y cents, or 5 cents, no, or 5 y 5 cents. Yeah. So then 25c. So this equal 57. So total money is 57. So the question is, what is, we want to find this x plus y plus z. These numbers are maximum or minimum. So if we consider maximum, then we pick this x as big as possible. So let's say so because 2x even out, 57 out. So we just check this, like let's say y, let's say x, y, z. We just pick this as 0, but we cannot put y as 0. We have to use y as 1, 5 cents. Then we have 52 left. So we need 26 2 cents, right? Okay, so in this case, x plus y plus z maximum is 27. So if we consider minimum, Then we just try let this z as large as possible. So this z, largest z, could be 2, right? 2. 2 25 cents is already 50. So we just need 7 cents. 7 cents. So here, so we just pick 1, 7 cents, and 2, right? Yeah. So for this problem, quite the same. Like we have those packs. This we have packs of 6 cans, 12 or 24 cans, and you wanted to buy 90 cans. So how many those? How many those 6? Or how many those pack for 12? How many for this pack for 24? So we have this. We say put this. This 6 packs as x of them. So we have so many cans. 6x so plus 12y plus 24z so equal 90, right? So we want to find number of packets. We just want to find x plus y plus z. We want to find smallest one, minimum. So we just try to find this as small as possible. Then this z, we just pick it as large as possible, right? So x, y, z. So we just pick it largest z. Largest z could be 4 or 4 not okay, right? Because 24 multiplied 4 is more than 90. So is 3. So 24 multiplied 3. So we have only 18 left. So this 18 cans, we can use this as 18 cans. Oh, so just use this as this one, yeah. Okay. Okay, so this problem says this guy has a draw 4 of those socks. Each of which is red or white or blue. Okay. So there at least they have 5 of them for each of them. So this guy pulls out one sock at the time without looking. Just pick one and one and one. So the question: how many socks must the Martin remove from the drawer to be certain that there will be 5 socks of the same color? So we just check the let's see, we just check a best case or worst case. Best case is the first one, second one, third one, fourth. Okay, just need the best case is if we pick up 5, all those 5 are red, so we get 5 circles of the same color. So this is best case. So worst case, first one, second one, third one, first one, second one, first one, second one. Okay, so by now, so what's the case? We pick so many, 12, right? Still no 5 circles of the same color. So if we pick one more, we can guarantee, right? So this number should be 13. for this one, which one cannot be the function value? So we just check some extremes situation. X, so here x is larger than 1. So we just check x close 1 or x become very, very large. We just check there's two situations, two extreme situations. So when x close to 1, so we find this number 2x plus 1. So we just pick x close to 1, so we find this could be really, really large, right? Could be go to infinity. So if x goes to infinity, this is 2x plus 1 or x minus 1. This number could be close to 2, right? Let's say like x equal 1000. So numerator is just like 2000, denominator looks like 1000, so this will be closer to 2. Okay, so those number can be like cannot, so this number can be any number from 2 to infinity, but it cannot be exactly 2.